Here is an example on solving a second order equation, and obviously it has constant coefficients. So if I write this out, I have y double prime minus y prime minus 6y equals 0, which would imply a is 1, b is negative 1, and c is negative 6. What is the key to find the solution to a homogeneous linear equation with constant coefficients? Finding the auxiliary equation and the roots. What is the auxiliary equation here? It is m squared minus m minus 6 equals 0. Now that is a quadratic equation, and there are two ways to find the roots. Either you can factor, or you can use the quadratic formula. It so happens that this particular example, we can just do it by factoring. The two factors are m minus 3 times m plus 2. Set the first factor equal to 0, or set the factors equal to 0, and solve for the roots. So I set m minus 3 equal to 0, which would give me m to be 3. I set m plus 2 equal to 0, which would give me m equals minus 2. So the two roots are m1 equals 3 and m2 equals minus 2. If 3 and minus 2, they're not the same, so the roots are real and distinct. And we know what the solution to the equation is if the roots are real and distinct. So the solution is y equal to c1 e raise m1x plus c2 e raise m2x. So we have c1 e raise 3x plus c2 e raise minus 2x. And I want you to try plug in the solution to check if the equation is satisfied. And it will be satisfied because we have the correct solution. Second order equations are typically easier to solve because we only have to find two roots, and we can either use factoring or quadratic formula to find the roots. So here we have y double prime minus 4y prime plus 5y equal to 0. So a is 1, b is negative 4, and c is 5. So the first step is to find the auxiliary equation and its roots. So what is the auxiliary equation here? It is m squared minus 4m plus 5m equals 0. Again, that is a quadratic equation. And we have two ways to solve. We can either factor or use the quadratic formula. Could we factor in this case? Let me see. I don't think so. So nothing's going to work out here. So let's use the quadratic formula. M equals minus b plus or minus square root of b squared minus 4 times a times c over 2 times a. So we have 4 plus or minus square root of 16 minus 20 divided by 2. So we have 4 plus or minus square root of negative 4 divided by 2. If I pull the 4 out of the root, I'd have 2 square root of negative 1 over 2. But we know that square root of negative 1 is I, so we have plus or minus 2i divided by 2. We could cancel out the 2's, so we have 2 plus or minus I. And you can see that the first root is 2 plus I, and the second root is 2 minus I. So this is what we mean by complex conjugate pairs. And I've mentioned this before in the background video that if you have complex roots, they will always occur in pairs. And if the equation has complex roots, you cannot make use of a calculator to find the solution. You just will not be able to. So what do we know? So we know if we have complex roots, then the solution is y equals c1. I'll pull the e raised alpha x out. E raised alpha x multiplied by c1 cosine beta x plus c2 sine beta x. Now, even though we have two roots, they are complex conjugate pairs. So if we have alpha and beta, it would be the same for its pair also. What do I mean by that? So here we have 2 and 1i. I times 1 is I. So alpha is 2 and beta is 1. So the solution would be e raised 2x multiplied by c1 cosine 1 times x plus c2 sine 1 times x. So we get e raised to x c1 cosine x plus c2 sine x. And that is it. And you could try at home to see if it satisfies the equation. it will satisfy the equation. So here we have a second order equation with constant coefficients, a homogeneous equation. 2y double prime plus 2y prime plus y equals 0, which would imply a is 2, b is 2, c is 1. They're all constants, so we find the auxiliary equation and its roots. The auxiliary equation here is 2m squared plus 2m plus 1 equals 0. We could use the quadratic formula, so m would equal minus b, so minus 2, plus or minus square root of b squared minus 4 times a times c divided by 2 times a. That would give us minus 2 plus or minus square root of 4 minus 8 divided by 4. Minus 2 plus or minus square root of minus 4 divided by 4. If I pull the 4 out of the root, it becomes 2. We have square root of negative 1 divided by 4, which would give me minus 2 plus or minus 2i over 4. I could cancel the 2 out, so I have minus 1 plus or minus I divided by 2, which I could write it as minus half plus I times 1 half. That will be the first root, minus half minus I times 1 half. That would be the second root. So alpha is negative 1 over 2, beta is positive 1 over 2. So we know that the solution to the DE with complex roots, by DE I mean homogeneous with constant coefficients. The solution is simply e raised alpha x multiplied by c1 cosine beta x plus c2 sine beta x. E raised alpha x, which would simply be e raised minus 1 over 2 times x. c1 cosine beta is 1 over 2. c2 sine 1 over 2 x. So the solution is e raised negative x over 2, c1 cosine x over 2 plus c2 sine x over 2. Here is another second order equation. So the equation is y double prime minus 10y prime plus 25y equals 0, which would imply a is 1, b is minus 10, c is 25. So the step here is to find the auxiliary solution, equation, and its roots. So the auxiliary equation here is m squared minus 10m plus 25 equals 0. Could we factor this? Yes. I could write it as m minus 5 times m minus 5 equals 0. Set the factors equal to 0. And solve for m. So if I set the first one equal to 0, I get m equals 5. Set the second one equal to 0, I get m equals 5. So the two roots are m1 equals 5 and m2 equals 5. And this is a real repeating roots case. So the solution to a homogeneous DE with repeating roots and constant coefficients of course, we're talking about a second order DE, is simply C1 e raise mx plus C2 x e raise m times x. So the solution here is C1 e raise 5x plus C2 x times e raise 5x. So now we are entering a bit of difficult territory. We have a cubic equation. So and that's what we have. And I know what the solution is just by looking at it. And let's write the auxiliary equation. The auxiliary equation in this case is m cubed plus 3m squared plus 3m plus 1 equals 0. Oh my. Technical difficulties here. There we go. So I'm going to make use of a calculator to find the roots. So let's see if it works. Something tells me that it is not going to work. So I'm going to enter the function here. So instead of y or instead of m we have x. So x cubed plus 3x squared plus 3x plus 1. And second mode to quit. and I believe it's second calc, and you can see that it says 0, so I'm going to find the 0 somewhere over there. Let's adjust the window. So we can see things better. And that's what we have, and it seems like the zero crossing is happening on the negative side. So what I'm going to do is I'm going to pick a left bound, so I'm going to move the arrow because I know the 0 is right there by the axis. You can change the window a bit more to identify exactly where it crosses. So I'm going to find the left bound. I'm going to move up and enter the right bound. And I'm going to ask the calculator to guess for me. So enter. And it gives me y is equal to 0 and x is equal to minus 0.9999. But I know that the root here is 1. So the root is m equals, negative 1. So what we have is m1 equals negative 1. But this is a cubic polynomial. That would imply that there are 3 roots. And we have found one of the 3 roots, and we've got to find the other 2. There are 2 possibilities. The other 2 are real and repeating, or they are complex and they are conjugate pairs. So if you know the binomial theorem, then you just by looking at it, you can realize that it is real and repeating. So I'm just going to go ahead and write a very general formula here. If we have x plus a cubed, then that would equal to x cubed plus 3a squared x plus 3ax squared plus a cubed. If we have x minus a cubed, we have x cubed minus 3ax squared plus 3a squared x plus a cubed. Minus a cubed. That is a standard formula, and it seems like we've got something that matches an equation that matches this. So by direct comparison, does it work out? Let's see. If we have x cubed plus 3x squared plus 3x plus 1 cubed, 1. And if we make a direct comparison, you can see if I compare it to that equation, we can realize that A is 1. So 1 here, 1 there, 3, 3, 3, 3, 1, 1 cubed. So A is 1. This would imply the auxiliary equation m cubed plus 3m squared plus m plus 1 is simply m plus 1 cubed. So the m 1 equals negative 1 that we found is real and repeating. And the three roots are m1 equals m2 equals m3 equals negative 1. So the solution to the DE is y equals c1 e raised m1x. Since it is repeating, c2 x e raised m2x and c3 x squared e raised m3x. Why are we putting x and x squared here? Because the roots are repeating. So the solution is c1 e raised negative x plus c2 x e raised negative x plus c3 x squared e raised negative x.